Hi everyone, welcome back. Today we are going to do some numerical based on test statistics. Okay, first question. A company tracks 8 employees productivity. So 8 employees productivity. Before and after a training program. Same sample, but you are checking before and after a training program. So same sample, you are doing before after test. That means you will go for t test. But which t test? Paired t test. Okay. Now let's do a numerical. The mean difference in productivity before and after training is 4.0. Mean difference. And standard deviation of difference is 1.69. N equals to 8 employees. So what is the calculated t value? See, this is the formula. Formula you have to remember. T equal to mean of differences 4.0 divided by standard deviation of differences 1.69. Sample size 8. So root over of 8. Okay. Now you have to use the calculator and you can calculate. Next question. A university compares average GPA of male and female students from two separate classes. N equals to 40 each. Male, female. See, you can see that separate classes, independent samples. So you will go for independent samples t-test. Okay. Now let's say n equal to 40 for both case. Okay. Mean equals to 3.2, standard deviation 0.5. Mean 3.5, standard deviation 0.4. Now you have to calculate t value. For independent t-test, to calculate t value, you have to use this formula. M equals to mean 1 3.2 minus M2 3.5. Right? Divided by root over of S1 square 0.5. So 0.5 whole square by N1 is 40 plus S2 0.4. 0.4 whole square divided by N2, that is 40. Okay, now you can use calculator and solve this. Fine. Next question. A researcher compares pass rates between two cities, city A, city B. Here 120 passed out of 200. And here city B 150 passed out of 250. And you have to compare the pass rates. So you can understand there is a proportion concept. Whenever there is a proportion concept, which one will you use? Z test for proportions. We discussed all these things in our last class. Now let's do the numerical. So for P1, 120 by 200 equals to 0.6 pass rate. P2, 0.6. Same. Now pooled P is 120 plus 150. Total they have passed among 200 and 250. So 200 plus 250 equals to 0.6. Okay. We have got all the things P1, P2, P. Now you have to calculate what is standard error. Standard error formula is this one. Root over P into 1 minus P into 1 by N1 plus 1 by N2. So we can write pooled P 0.6. 1 minus P 1 minus 0.6 into 1 divided by N1. So 1 divided by N1 is 200 sample size. N2 is 250. Now you calculate this, you will get standard error. Okay. Now what is G-score? G-score formula is P1 minus P2 divided by standard error. So here P1 is 0.6 minus P2 is 0.6 and divided by whatever the value we get from here. Right? But 0.6 minus 0.6 equal to 0. So the final value will be 0. Okay. Now next one. A study checks if preference for 3 types of juice is equal among 150 people. So you can see this is a category. I told you for category you have to go for chi-square test. Chi-square test is of 2 types. One is goodness of fit. Another is taste of independence. Right? Goodness of fit when used to check whether the observed frequency fit an expected frequency. So here you have observed frequency and expected frequency. Okay. But taste of independence to check whether two categorical variables are independent or associated. Okay. So you just have to remember this thing. Independent or associated. Fine. Now let's do the numerical. For group A 50, for group B 45, for group C 55. These are observed. What is expected? For everyone it is 50 divided by 3. Now you have to calculate chi-square. This is the formula. Observed minus expected whole square divided by expected. So for first group 50, observed is 50, expected is also 50. Okay, square divided by expected. Same, observed 45, expected 50, square divided by expected 50. Again, observed is 55, expected 50, square divided by again expected, so 50. So if you add them, then you will get some 0 plus 0.5, so it will get around 1. Okay. Next one. A scientist compares average test scores among 4 teaching methods. So I told you whenever it's greater than 2, you have to go for ANOVA. Okay. Now next do the numerical. 4 teaching methods, n equal to 5 each. Group A 70, 72, 75, 78. So grand mean is 73.75. Okay. Now between group sum of square is 150. Within group sum of square is 100. Degree of freedom between is 3. Degree of freedom within is 16. You have to calculate what is F statistic. Simple formula, you have to calculate mean square between divided by mean square within. Now mean square between equal to sum of square between divided by degree of freedom between. So sum of square between is given 150. Degree of freedom between is 3. So it will be 50. Now mean square within groups. So mean square within equal to sum of square within by degree of freedom within. Sum of square within is 100. Degree of freedom within is 16. So it will be around 6.25. Sorry, 6.25. Okay. Now once you get them, now you can simply write F equal to MS between by mean square within. So mean square between is 50, mean square within is 6.25. Okay. Now you can calculate whatever the values. Okay. Now let's do the next one. A nutritionist wants to check if average daily protein intake of adults in a town is significantly different from the recommended 50 gram per day. So she collects a sample of 25 adults. So here see 25, that means less than 30. So you will go for t test. But which one? You have taken one sample of 25 people. So one sample t test. Okay. Now let's do the numerical. See, sample mean is 54. Sample mean is denoted by x bar. Population mean is 50. So this is 50. Sample standard deviation is 5. And sample size is n equal to 25. Now you have to calculate t. So the formula is x minus mu divided by s by root over of n. So sample mean 54 minus population mean 50 divided by standard deviation 5 by root over of sample size 25. 54 minus 50 is 4 divided by 1, so ultimately 4. Okay, got it. Now next, a factory claims that the average lifetime of its bulbs is 1000 hours. Okay. A quality inspector collects a sample of 36 bulbs. Now the population standard deviation is known. See, known means population standard deviation known means you will go for G test and to be 60 hours. Then which is appropriate. And here you are calculating means, so you will go for G test for means. Okay. Now let's do the numerical. So sample mean is given, population mean sigma n. So x bar minus mu by sigma by root over of n. Same formula. So sample mean 950, population mean 1000, sigma 60 divided by root over of 36. Whatever the answer is. Okay. Next one. A researcher wants to test whether gender and preferences are related among 200 people. Gender preference of tea coffee. Categorical variable. So obviously you have to go for chi-square. Chi-square is of two types. Goodness of it, taste for independence. I told you to check whether two samples are associated or independent, you have to go for chi-square test for independence. Okay. Now let's do the numericals. See, male tea prefer 30, coffee prefer 50, so total 80. Female 70, 50, total 120. Now 100 people prefer tea, 100 people prefer coffee, total 200. What is the expected frequency for male and tea? See, this is the formula. So you have to use row total into column total by grand total. So male means you have to consider this row. This total is 80. T means this total is 100. So 80 into 100 divided by what is the grand total? That is 200. So the answer is 40. Okay, so we have discussed many questions. First of all, how to understand which statistic to apply, then how to apply the formula. After you calculate this, it will help you to do the hypothesis testing. Okay, so meet in our next class. Till then, bye. Happy learning.